Hey, Miss Miklos here with your Chapter 7 review, and I'm just going to go through a few problems from each section. If you need help on one that I'm not covering, please come in and see me, or feel free to email me so I can get back to you and let you know how to do that particular problem. We're going to go ahead and start off with number 3. So looking at number 3, I have 9 to the negative 5 halves power. The very first thing I'm going to have to do here is rewrite this so that I have a positive exponent. So I'm going to make it 1 over 9 to the 5 halves. Now, I know that I cannot have this improper fraction as my exponent because we can simplify this further. So I'm going to have to think of this as 1 over the square root of 9 to the 5th power. Because we know when we're changing back and forth, my denominator becomes my index number, my numerator becomes our exponent. And this 5 can either go inside or it can go outside like I've written it. The reason why I wrote it this way is because I know the square root of 9 is 3. And when I go ahead and simplify this, I get 1 over 243 because that is 3 to the 5th power. So some key things I want to just kind of point out here. First of all, when I have a negative exponent, I need to bring it down to the denominator. Secondly, when I have a fractional exponent, we know that the numerator is my exponent, the denominator is our index number. Next one I want to look at is number 9. Here I have 81x to the 1/4 power. And I'm actually going to go ahead and rewrite this as the 4th root of 81x. And I'm going to do a little bit of a factor tree here. I know 81 is 9 and 9, so this is 3 times 3, and this is 3 times 3. This index number of 4 tells me I need a group of 4 things to take it out. So I can take this 3 out. Unfortunately, I have this x left over, so I have the 4th root of x. So my answer is 3 4th root x. That's as much as I can simplify. The other answer that I would accept would be 3 times x to the 1/4 power. Notice in our original problem, I knew both of these quantities was being taken to the exponent because of the parentheses. In this answer, only the x is being taken to the exponent. 3 is not connected because it's not in parentheses. The next problem that I want to go through is number 13. And the reason why I'm choosing this one is this was a tough one for a lot of you guys on our quiz. And we definitely are going to see stuff like this on our test. So the first thing I'm going to do is split this up. So I have the 5th root of 3 over the 5th root of 4. And this 5th root of 3 is totally fine because that's in our numerator, but I know that I cannot have this in my denominator. So I need to think a little bit, and I know 4 is 2 times 2. This index number of 5 tells me I need a group of 5 to take things out. So I'm going to multiply the numerator and the denominator by the 5th root of 2 times 2 times 2, or you could have written 8. The reason why I needed 3 2's is because now if we count them, we have 1, 2, 3, 4, 5. So I can actually take all 5 of these out, and my denominator becomes a 2. In my numerator, I have 3 times 8, which becomes the 5th root of 24. So what makes these a little bit more difficult than when we just had a square root is we need to put some thought into what are we missing. Okay, if this had said the cube root of 4, I would have only been missing 1 2. If it had said the 9th root of 4, I'd be missing 7 2's. So each problem is different depending upon what our index number is. Our next one here is number 14. I have the cube root of 16 minus the cube root of 2. And if we look at this, I notice I have the same index number, so we know that that is one of the two things that we need. If this had been multiplication, we could just multiply straight across. However, when we are adding or subtracting, I need the same index number and the same radicand. So I'm going to have to go ahead and simplify this a little bit. So I'm going to do a factor tree of 16, so I have 4 and 4. So I get 2 times 2 times 2 times 2. And I have this group of 3 that we can take out. And I have a 2 left over. So I have 2 cube root 2 minus cube root 2. At this point, I can just combine the coefficients, and 2 minus 1 is just 1, so cube root 2 is my answer. So just rule of thumb, when we're multiplying or dividing, I need the same index number. If I'm adding or subtracting, I need the same index number and the same radicand. So I know I'm kind of jumping all over the place here, but the next thing that I want to do is f of g of x. So I'm going to go ahead and do f of x minus 8. I know that we always start on the inside, and this is really just a fancy way of looking at substitution. So this means in function f, wherever there's an x, I'm replacing it with x minus 8. So I'm going to have 3 times x minus 8 to the negative first power. Now looking at this, I know only the x minus 8 is being taken to the exponent because the 3 is on the outside. According to order of operations, I need to take care of that exponent first. So I'm just going to bring that entire quantity down into the denominator. So my answer is 3 over x minus 8. So composition, I'm just substituting in for x, replacing x with whatever's inside my parentheses. Next, we're doing the mysterious number 24, because I don't know why it doesn't say. Oh, maybe that's a hole punch. Whatever. Anyways, the whole point is it's telling me to find the inverse function. So we remember with an inverse function, we switch and then we solve. So I'm going to switch x and y. And I know f of x represents y, so I'm going to write x equals 1/2 y plus 6. Now I need to isolate y, so I'm going to subtract 6 from both sides. And then I'm going to multiply everything by 2, because that is the reciprocal of 1/2. So I end up getting 2x minus 12 equals y. We could also write this 2x minus 12 equals the inverse of f of x. So switch x and y, solve for y. 27 is telling us that f and g are already inverses, so we need to verify. And we had stuff like this on our quiz where I need to find f of g of x and I need to find g of f of x. So I need to do both of those. So this first one, f of x cubed minus 1, would be x cubed minus 1 plus 1 to the 1/3 power. Now when I'm looking inside my bracket here, my 1's cancel out. So I have x cubed to the 1/3 power, which becomes x. So I know I'm halfway there because my goal is to get x. So here I'm going to do g of x plus 1 to the 1/3, which would become x plus 1 to the 1/3 power cubed minus 1. When I multiply the 1/3 and the cubed, I end up getting 1. So I have x plus 1 minus 1, which is x. So when it's telling me to verify, I need to prove that f of g of x is x and g of f of x is x. I need to see all this work in order for you guys to receive full credit. Final concept of the chapter is solving. So we're going to look at 29. I like this one because the first thing I need to do is isolate whatever's being taken to either the radical or to the exponent. So I'm going to start here by subtracting 5 from both sides. So I get 6. Then I need to divide both sides by 3. So I have x minus 1 to the 1/5 power equals 2. So I've succeeded in isolating what's being taken to a power. So now I need to think, what power should I raise both sides to get rid of this 1/5? And I'm thinking we should raise both sides to the 5th power, because 1/5 times 5 becomes 1, which would just make this x minus 1. I know 2 to the 5th is 32, so I get x equals 31. Now, before I know for sure that that's correct, I need to make sure that it's not extraneous. So I need to check. Is 3 times 31 plus 1 to the 1/5 power plus 5 equal to 11? So in my calculator, if I do 32 to the 1/5 power, I get that it's 2. So 3 times 2 plus 5 is equal to 11. So x equals 31 is our answer. If we had found that this wasn't true, then we would write our answer as no solution, because we would not have a solution that actually works. Last one I'm going through is number 30, and I think this is actually the most difficult of all of them, because I have 2 different radicals and I don't have the same radicand, so I can't add them together. So the first thing I'm going to do is split them up. So I have 1 plus the square root of x minus 1. So I need to start by squaring both sides, and the left side just becomes x plus 3, but the right side becomes a FOIL problem. So I'm going to have to go ahead and do 1 times 1 is 1. 1 times radical x minus 1 is radical x minus 1. Radical x minus 1 times 1 is radical x minus 1. And lastly, radical x minus 1 times radical x minus 1 is x minus 1. So I need to go ahead and add all my like terms together. My 1's actually cancel out, so I am left with x plus 2 square root x minus 1. I'm going to subtract x from both sides, so I get 3 equals 2 square root x minus 1. And the reason why I'm doing this is because now I have a radical left, so we need to isolate that again. I'm going to go ahead and divide both sides by 2. So I get 3 halves equals the square root of x minus 1. I'm going to square both sides, and I end up getting 9/4 equals x minus 1. So 13/4 equals x. And you guys may remember seeing this one in our notes. Now I need to double check my answer, so I need to check, is the square root of 13/4 plus 3 minus the square root of 13/4 minus 1 equal to 1. So let's check. I would get the square root of 25/4 minus the square root of 9/4. So 5 halves minus 3 halves is equal to 1. So I know that that is a true statement, and 13/4 would be our solution. So this was just a really brief, quick overview of the chapter. If you were struggling on some particular lessons, especially section 7.2, I would re-watch that lecture. Please come and see me if you need help, and study that quiz that we took. If you guys want to, if you haven't gotten your quiz back, feel free to come in and pick it up from me, so that way you guys can study off of it.